Okay, let's have a look at 1e. It says find the local minimum value for the function, this thing here, and justify your answer. So, all right, so we've got y is equal to x cubed, x minus 4. So let's expand this out a little bit. So y, therefore, is equal to, well, that times that is going to be x to the 4, and this times this is going to be minus 4 x to the 3. Okay, so in order to find a maximum minimum, we're going to have to differentiate, find the differential function, dy dx, is equal to 4x to the 3 minus 4 3s are 12x to the 2. Now we can go ahead and well, we can factorize this, and that's going to be, we're going to have 4 outside the bracket, 4 is common, also x squared is common as well. So that's going to be, we've got a 4 common, if I put an x there, and 4 times what makes this is going to be minus 3. So let's make that equal to 0, and now we can say, well, either 4x squared is equal to 0, therefore x squared must equal 0, or x is equal to 3. So we've got, therefore x is 0, and you have to even put x squared there. So we've got an x is 0, and we've got an x is 3. There are 2 values. Now, we want to test both of those and see, because the question says find the local minimum value. Okay, so let's test them. So test x equals 0 for minimum, or min-imma, I should say. Okay, so let's go ahead and do that. So we're going to find the second differential test. So this is going to be d squared y over dx squared is equal to, well, here's the old one here, and we're going to go ahead here, and we're going to differentiate that once more. So 4 3s are going to be 12x squared, and 12 times 2 is minus 24x. So when we throw a 0 into there, equals 0 minus 0 is 0. What we've got here, this is not actually a maximum or minimum. This is a point of inflection. Therefore, d squared y over dx squared is equal to 0. Therefore, x equals 0 is a point of inflection. Yeah? Now, that's not really helpful to us because we're trying to find the minimum. So let's test again for the other one. So let's go now. Test, I'll put x is equal to 3 for minima. All right, so now we're going to have d squared y over dx squared is equal to 12 times 3 squared minus 24 times 3. Well, 3 squared is 9, and 9 12s are 108. Minus, well, 24 times 3, that's going to be 72. 72. And this, of course, is going to be a positive number. So therefore, we can say, therefore, d squared y over dx squared, and we're going to have to say here, is greater than 0. You could actually work out what it is, by the way, but I can't be bothered. It's going to be greater than 0. Therefore, x equals 3 is a minimum. Or let's go a local minimum. Let's use the language they use, yeah? Is a local minimum. Now, I don't know if they want you to do anything else here. You could state what y is when that's true. Do they say what are the coordinates? Do they ask you the coordinates? Well, they say, here it is, find the local minimum value. And the local minimum value must be an x and a y. It must be a coordinate. So there is the 3. Let's find y. Then we can say, well, what the value, the coordinate value is. So I think that's probably the thing to do here. So I'm going to say y is equal to, and we've got x to the 4 minus 4x to the 3. We're going to let x equal 3. So y is equal to 3 to the 4 minus 4 times 3 to the 3. So 4 to the 3 is going to be 81. 3 to the 3 is 27. And 4 times 27, well, that's a very interesting number. So 4 times 27 is 108. So we've got 81 minus 108, which is going to equal negative 27. So therefore, minimum is found at 3, negative 27. And there is the point.